What happens to the light that is striking this book? When you hold the book up to the light, you will see that no light passes through it. Recall from Chapter 16 that an object like this is called opaque. Part of the light is absorbed and part is reflected. The absorbed light spreads out as thermal energy. The behavior of the reflected light depends on the type of surface and the angle at which the light strikes the surface. Recall from Chapter 14 that when a wave traveling in 2 dimensions encounters a barrier, the angle of incidence is equal to the angle of reflection of the wave. This same 2-dimensional reflection relationship applies to light waves. Consider what happens when you bounce pass a basketball. The ball bounces in a straight line, as viewed from above, to the other player. Light reflects in the same way as a basketball. The animation shows a ray of light striking a reflecting surface. The normal is an imaginary line that is perpendicular to a surface at the location where light strikes the surface. The reflected ray, the incident ray, and the normal to the surface always will be in the same plane. Although the light is traveling in 3 dimensions, the reflection of the light is planar, or 2-dimensional. The planar and angle relationships are known together as the law of reflection. This law can be explained in terms of the wave model of light. The animation above shows a wavefront of light approaching a reflective surface. As each point along the wavefront reaches the surface, it reflects off at the same angle as the preceding point. Because all points are traveling at the same speed, they all travel the same total distance in the same time. Thus, the wavefront as a whole leaves the surface at an angle equal to its incident angle. Note that the wavelength of the light does not affect this process. Red, green, and blue light all follow this law.